Welcome back, and here we're going to do some more complex loops here. Okay, so we're going to start off by writing a couple here. I have one already, but just before we go and dig in here, I'm going to remind you that we did this little piece here about the break and the continue and the return. I'm going to take this piece here and just simply break, because return is such a strong break that it would probably mess with the rest of the code that comes down here. So I don't want that, so I leave break. So this is going to just go 10, 9, 8, 7, 6 and stop at 5. Will not print 5. So I'm breaking on 5 here, and we jump right in. So let me just run this just to see that we could see those numbers there, and that was the 10, 9, 8, 7, 6. Okay. So I'm going to go ahead and do the first one. Here we are talking about printing horizontally. So let's scroll to get that out of the way. We want to print sequences. So we're looking at printing these, the number 1, 8, 27, 64, and 125 to 16, and so on. You got to figure out a pattern here. You got to figure out what's the pattern, because loops are patterns. So if I'm looking at this, it looks like this is a cubic pattern. It looks like it's 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, all the way to 10 cubed. So I have my for loop all set up, and I fill this one in already. I'm starting at 1, stopping at 10, and I'm doing math.pow, cubed root. Okay, so I'm taking I, raising it to the third power, printing it, putting a space between, and running it. So here's what we get. Oh, look at that. We got the numbers, but we got them as doubles. Well, we don't want doubles. We want ints. So how do I do that? We cast it. See how everything is coming back? See how everything is kind of filling in? Okay, we got to cast that to an int. Let's run it again, and there we have them. Okay, now this is not the only way to do this, but this is the easier way to do it. So you want to always look for the easy way to do these things. You don't want to do things too complex. Okay, we jump to the next one. We're just going to fire them all one after the other. So here we go. We got -2, 4, -6, 8, -10, 12, -14, 16, -18, 20. So there's this alternating sign, and then there's this times 2 business. All right, so you could see it as adding 2, right? You can see that without the negative, you can see like 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. Or you could see it as starting at 1 and stopping at 10. So we go 1 times 2, 2 times 2, 3 times 2, 4 times 2, 5 times 2, 6, 7, 8. You may say, well, wait a minute. I see that. So how do you get a plus or minus? Let's try it. That's int I. We're going to start at 1. I less than or equal to 10. I plus plus. Okay, so we're going from 1 to 10. And we want to print I times 2 with a space. Let's try that and see what we get. So we get 2, 4, 6, 8, 10, as we expected, right? Because we don't have any negatives in here. Okay, so now the question becomes, how do we get this plus and minus? Okay, well, we could do this a couple of ways. We could get a variable that would be responsible for multiplying this by a negative number, or multiplying it by a positive number sometimes, a negative number sometimes. We could do that, or we could recognize that when this is 1, we're doing this guy times 2, right? We don't have the negative yet, so we realize 1 gives me a negative, 2 gives me a positive, 3 gives me a negative, 4 gives me a positive. So there's this odd and evens, right? So it looks like if I is even, let's see, this is odd. This is odd. If it's even, just do this. Otherwise, let's do this. Right? Looks that way. Let's try it and see what we get. Voila. Got it. -2, +4, -6, +8, -10, right? Just like this. See, what I did there, I realized that my pattern had an odd even thing to it, and I realized that the odd even is where the positive and the negative are happening. So you got to look carefully for these patterns, and once you spot them, then it's easy to write. The question is, can you see them? Let's go to the next one. All right, so we got 128.0, 64.0, 32.0, 16.0, 8.0, 4.0, 2.0, 1.0. Don't want to mix this up so it gets this convoluted thing. If you look at this, I hope you see a byte. I hope you see a byte. And if you're not seeing a byte, gotta remember 2 to the 0, 2 to the 1, 2 to the 2. But however, these are doubles, so we gotta make sure when we finish up we get doubles here. And we gotta start at 7. I must be greater than or equal to 0. And it's I minus minus. We're going backwards. I'm going backwards, right? I'm going 128 first, then 64. So I want to print math.pow 2, comma, I with a space. Every time we do this, we add a space. And again, this adding of a space make this is a string here, and then turns this into a string. Let's see if that works. How about that? Let's try that. Got it. 128, 64.0. See, if I needed this in ints, I will just cast this, just like I did above here. So far so good. You gotta spot the pattern, and it becomes easy. So one of the things you gotta do is you gotta pay attention and watch the patterns carefully. So we have 0, 3, 8, 15, 24, 35, 48, 63, 80, 99. All right, this is a tough pattern. This is a tough pattern because you could think add 3, but then if you add 3, we would have gotten a 6. That doesn't work. Add 3, then we add 5, then we add 7, then we adding 9, and it's a little tricky. So I'm looking at this and I'm seeing something else as well. I'm seeing, what if this was one more? What if this was an extra 1? Like if this was a 1 more, it would have been a 1, then a 4, then a 9, then a 16, then a 25. Look like I'm squaring, and a 36, and a 49, and a 64, and an 81, and a 100. Look like I'm squaring this thing, but I'm also subtracting 1, right? So I'm going to say int I start at 1, I less than or equal to 10, I plus plus. I did a lot of these things going to 10 because I want you to see it doesn't matter how it shows up, it could still be starting at 1 and stopping at 10. A lot of students make the mistake and think every time they'll see this, they'll go, oh, start at 0, stop at 99. I mean, you could do that, but the problem is then if you do that, you make a complicated question even more complex. So look for the pattern and look for like 1 through 10 or something easier to manage, and then write your code. So right now I'm looking at this and I'm thinking it's going to be I times I minus 1. Now you say, why do you write this like this and then use math.pow? Well, I'm just showing you a different way to write it. Let's try and see if that works. Alright, so we have a bunch of numbers here, and this doesn't help me out here because you know why? We didn't put a space. Okay, so let's put a space. Doesn't look good, so let's see. Alright, looks good. So we have 0, let's put it in view, 0, 3, 8, 15, 24, 35, bingo, we got it. Next one. The next one is -3, 7, -11, 15. Oh, it looked like it's adding 4. So let me just go int I equals 3, I less than 32, I plus equal 4. And I'm going to print I. Now you realize I'm not worried about the plus and minus yet. I'm just trying to see if I get 3, 7, 11. Let's try and see if we get that. 3, 7, 11, 15, 19. Okay, so look like it's right in terms of the numbers. Now we got to figure out the sign. So to get this plus minus, we could make another variable. I mean, we could have used I and figure it out, but sometimes it's better to just use another variable. So let's call this negative, and we make it -1. So the way we're going to do this is we're going to say whatever the I is times negative. Now, because it's -1, it's going to make everything negative right now. So if I run this, it's going to be everything's negative. And that's okay. All right. We just need to figure out which one's supposed to stay as negative. So what we're going to do then is we are going to update the negative. We're going to say negative times equal -1. So what am I using here? I'm using a negative times a negative is a positive. See, first time it comes in, it's negative. You multiply the I, which is 3, by a negative, you print a -3. But then negative changes to positive because -1 times a -1 becomes a positive. So when this goes +4, which is 7, when it cuts here, it's going to be 7 times a +1. And then we're going to go again and multiply it by a negative again. So sometimes this is flip-flopping between negative and positive. So I'm going to run that. There we go. -3, +7, -11, +15. Perfect. Next. So right now, this one is starting 0, 1, 1, 2, 3, 5, 8. Well, this is a tough one. I mean, what? Don't know where to start and how to end this one. Well, this is a famous sequence. It's called Fibonacci. Let's put a little note there. Fibonacci sequence. And if you've never seen it, it's okay because I'll tell you how it works. The way it works is it takes the two from before, add those two to get the next one. So this 2 is coming from these two from before. And this 3 is coming from these two from before. And this 5 is coming from adding these two from before. And this 8 is coming from adding these two from before. And this 13 from 8 plus 5 and so on. So there's this kind of memory thing going on here where there's something that happened before. We got to add them up to get the new one. And then when we get the new one, we print it and then we keep going. So this one's a little bit tricky. So let's see. Let's say we're going to have this int value 1 and started at 0, and int value 2 and started at 1. Now I'm using these two because I don't want to confuse the counter with the values. So I'm going to say int I equals 0, I less than, let's see how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10, I plus plus. I'm going to run this loop 10 times. And I'm going to use these guys to figure out the next guy. So the first thing we need to do is system.out print, and we're going to print value 1, value 2, right? Because this is the 0 and this is the 1. So we print these two. The next time around, we're going to print value 1 plus value 2. Okay, so basically we've just printed the 0, the 1, and then we've added them together to get a 1. So now we've printed this. So right now our loop is at this point. So some things need to change. So the value 1 needs to become the value 2, and value 2 needs to become the answer that we had before, right? So we got to shift them over. So value 1 is here right now, is 0. Value 2 is here right now. When this gets calculated, which is here, the value 1 is now going to become what value 2 was, And value 2 is going to become what the sum was. So let's do that. Value 1 is going to be value 2. And then value 2 is going to become value 1 plus, no, I shouldn't say that. Let me actually make a big change there. Copy int sum, so that we don't mess with the sum itself. And value 2 is going to become the sum. Okay. So basically I took the sum out and make a variable for it so I could hold it so I know what it is. So I want 3 values. I want at any point I should have 1, 2, 3. Let's run that and see what we get. Alright, we got to make sure we get what we have up here, and if we don't, then we made a mistake. So we got to go and fix it. Oh, whoa, look at that. I got 0, 1, 2, 0, 1, 1, 2, 3. So it's working, but look at this. I got some extra numbers here. Well, yeah, that's because we already printed 2 of them. So why am I going to 10? I'm going to change that to 8 and run it again. Let's look again. There we go. See, I already printed the first 2, so I shouldn't be stopping at 10. I'll be printing an extra 2. It gets me more than 10. So here we go. Last one. So now we're looking to print 2, 3, 5, 7, 11, 13. So this looks like odd numbers, right? But there's a little twist to this. There is this int and double, right? Kind of look odd-ish, or maybe not. The 2 is even. Let's see. And we go to 3. Then we go to 5. Then we go to 7. Then we go to 11. Then we go to 13. So how is this working out here? Well, it looks like if I go 3, 5, 7, 11, we didn't get 9, right? So something here that's a little tough is that this thing is skipping, right? This thing is skipping. I mean, 2. It's the only even number here. Okay. And then we go 3, 5, 7, and you will expect 9. But it didn't do 9. It went to 11. And then with 11, it went to 13. And with 13, it skipped 15. So let's make little notes here. Skip 9 and 15. So we skipped 9, 15. We skipped 21. Uh, 23. We skipped 25. Okay, we skipped 27. And then when we get to 29, we get to print 31 next. Okay, so this is a little strange here because we really got to think about what we're doing here. So I'm going to write my loop to say let's print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So I'm going to say int I equals 0, I less than 11, I plus plus. I'm going to try to do something that would print 11 numbers. I'm just going to put a value here. So int value. Actually, you know what we could do very easily is to just print the 2. Because the 2 is not part of this. So let's go down 1. Because the 2 is even and these are all odds. So I'm going to go ahead now and make a value. Let me call it val, starting at 3. And I want to print val with a space. But I want to make sure that val goes up by 2. But there's a little bit more, right? Because val does go up by 2, but it skips some. So what do? Put a selection. See, I had to show. Alright, so if val is 9 or val is 15 or val is 21 or val is 25 or val is 27. I'm going to write this really strange. Do nothing. Otherwise, print. See how that works? Do nothing. It's a nice way to write. This is a convoluted way to write it, but let's just run it and see what we get, and then I'm going to fix it to show you a different way to think about it. Let's see if we got it. We got 2, 3, 5, 7, 11, 13, 17, 19. Okay, so we are missing 23, 29, and 31. So clearly we are stopping this loop too quickly. So let's go out 2 more. Actually, we need to go out a lot more because I think we might still stopping a little early. 23, we need 2 more on top of that. So let's go to 14. See, now we skipped some. That's why we had to increase that number. So we get to 20. See, I'm at 29, so I need to go even higher. 15. Let's see. And now we get to 31. Now the other thing here is that some of these things are doubles, right? So how will this work here? So we want to see how can I make some of these things doubles, right? So we could say, because we're doing selection, right? Else if, right? We could say else if, and we're doing selection. If it's a 3 or a 7 or 13 or 19 or 29, print the double. Well, let's do that. Let's write it here. Else if the value is a 3 or val is a 7 or val is a 13 or val is a 19 or val is a 29. If that's the case, we're going to print the val, but we're going to print the double version of it. Okay, how do you do that? We cast it. I hope you're seeing how everything is coming together here. I'm doing perfect selection. So one of the things here is that I'm going to run this and see that I get the right thing. So 2, 3.05, 7.0, 11. So we're perfect here. I don't really like the do nothing. So what's another way to do this? Well, we could write this with a not. Right? If it's not these, then print it. Right? So we could write that with a not by rearranging this thing. I'm going to leave this as the solution, but I'm just letting you think that we could actually rewrite this by saying if it's not any of these, go ahead and print the thing by checking to see if it's one of these. And if it's one of these, we print that. And if it's not one of these, then we will print this. So a lot of ways to write this. I wanted you to see the nesting of the ifs here. I wanted to see the do nothing because of the selection. This was a tough pattern, so I used selection. And that's the whole idea of selection, right? Select what you want to print. That brings us to the end of this section of writing a little bit more complex loops. The next section coming up would be even more complex, but we would be hand tracing. The code is already written, and we want to figure out what happened. So we'll walk through them. Then after that, we will even write some more complicated loops, some more nesting of loops and a little bit more complex loops. But for now, quick recap. When you get a problem that has a pattern, you got to figure it out. And if you're writing this pattern with a loop, you have to make sure that your loop parameters are properly organized. Where you're starting, where you're stopping, how you're getting there. Do you need selection? Do you need an if statement? If you need an if statement to take things out, go ahead and do that. There are many ways to do this, okay? So I'm showing you the easy way. Think the easy way. You have plus or minus stuff. You want to make sure you can toggle between positive and negative, okay? Again, this brings us to the end of a little bit more complex loops.